In this video we're going to have a look at trial and improvement. So a typical trial and improvement question might look like this. I'm given an equation, quite a nasty one, x squared plus 2x equals 38, and I need to solve it correct to one decimal place. That doesn't mean that the answer will be exactly one decimal place, I just give my answer correct to one decimal place. So what I do is I set myself up a table, and in the first column I'm going to put guesses for the value of x. Nothing more complicated than that, it's just guessing values of x. And over here in the last column, something called a comment, which we'll come to in a second. So to start off with, I'm going to guess the value of x to be 5. So 5 squared plus 2 lots of 5 gives me the value 35. Now that's actually too small. So in this comment section, what I'm going to put is I'm going to put my comment on the comparison with the value I need, 38. So 35 is obviously too small. My next guess is going to be 6. And when I do 6 squared plus 2 lots of 6, I get 48. And my comment there is that it's too big. What I've actually done now is I've trapped the answer somewhere between 5 and 6. 5 was too small and 6 was too big. So the answer is somewhere in this region. So I'm going to start looking at decimal point values. So I'm going to start off by looking at 5.5. 5.5 squared plus 2 lots of it gives me 41.25. I compare that against this value of 38 and I can see that that's too big. Now because this one's quite a bit too big, what I'm going to do is I'm going to try a different value, but I'm not going to try 5.4, I'm going to try 5.3. And 5.3 is going to give me 38.69, which again is too big. Next I'm going to try 5.2, which makes sense because if 5.3 was too big, my next guess would have to be smaller. So I try 5.2 and I get 37.44. Now this one's too small. What I've got now is I've got the situation where my answer is trapped somewhere between 5.2 and 5.3, between a small value and a value that was too big. So my answer, because I need it to one decimal place, is either going to be 5.3 or it's going to be 5.2. What I need to do is something called a test value. The test value sits halfway in between these two at 5.25. So when I try 5.25, I actually get the value 38.0625. Now comparing this against what I want, 38, I can see that that is too big. Going back over to my number line, I tried 5.25 and that was too big. So logically, my next guess is going to have to be smaller, which means it's not going to be in this region here. It's going to be in this region. And anything in this region, if I round it to one decimal place, rounds to 5.2. So my answer correct to one decimal place is 5.2. It's important that I add in this test value to make sure that I can decide between 5.2 or 5.3 once I've got it trapped between those two values. In this second example, I'm going to do much the same thing. I'm going to use trial and improvement to solve this equation, and it's important to note that I need my answer to one decimal place. So if I set up my table again, and this column is going to be where I make my guesses for x, and over in this column, this is going to be quite important, I'm going to put my comment over there. So as a starting value for x this time, I'm going to pick the value 3. Now when I stick 3 into this equation up here, I actually end up with the answer 27, which I compare against this 35, and we can see that that's too small. So next up I'm going to try the number 4. When I put 4 into the equation, I end up getting 40 come out of it, which is too big because I wanted 35. So what I've done is I've now got the answer trapped somewhere in between the integer values 3 and 4. So there's only a few different numbers it can actually be here, 3.1, 3.6. So let's try smack bang in the middle. Let's go 3.5. When I put 3.5 into this, I get 33.25, which comparing it to my answer that I do want 35 is too small. So next I'm going to increase my guess to 3.6. When I put 3.6 into this, I get 34.56. And again comparing it, I can see that that's too small, but pretty close. Then I'm going to try 3.7, and when I stick 3.7 into this, I get 35.89. Now comparing it, this one now is too big. So what we can see is I've now got it trapped between 3.6 and 3.7. The sensible thing to do here would be to test the value in the middle of these. So I'm going to do a test value of 3.65. This will tell me whether it's closer to 3.6 or closer to 3.7. So when I try 3.65, I actually get 35.2225. Comparing that with what I want the answer to be, I can see that that is too big. Now going over to my number line, because this one was too big, my next guess would have to decrease in size, which means it would be somewhere in this region. And anything in this region will round to one decimal place as 3.6. So I'm confident that my answer to this, correct to one decimal place, is 3.6. Here's a question for you to have a go at yourself. Hit pause here. When you're ready for the answers, hit play and I'll talk you through it. Okay, so I'm going to need the table for this, just like in the previous examples, and my guesses for x are going to go here, and my comments in that section. So my opening guess for this one is going to be that x is 4. This churns out the value of 60, which is too small. My next guess for this one will be x is 5, and this gives me the value 120, which is too big. So it's now trapped between 4 and 5. So if I was to try 4.5, this actually gives me the value 86.625, which, comparing it to my 78, is too big. So the next value I try is 4.4. This one gives me 80.784, which again is too big. So I decrease my guess, I go 4.3, and when I put 4.3 into that equation, I end up with 75.207, which is too small. So I can now see that my actual value is trapped and lies somewhere between 4.3 and 4.4. That means that given an answer correct to one decimal place, it's either 4.4 or it's 4.3. At this point, I do my test value of 4.35, and when I plug that in, I end up with 77.962 and a few decimal places after that. I can still compare this against my 78, and I can see that that is too small. That means that my next guess would logically have to be bigger, which means anything there is going to round to 4.4 as my final answer. Here's a second question for you to have a go at. Pause the video here, hit play when you're ready to talk through the answers. Okay, in this second question then, exactly like the previous three that we've done, we're going to need to start off with our grid, and I'm going to label this column as where I do my x guessing, and over here, the really important stuff, the comments. So I need to make this equation equal to 270. So picking a value to start off, I can see that this is quite a big number, so I'm going to start with x as 6. When I plug that into my equation, I get 192, which is too small. So next one I'm going to try is 7. When I stick 7 into this equation, I end up with 315, which is too big. And that's quite nice because it's now trapped between 6 and between 7. So I can start exploring the decimals. If I try 6.5, then what I end up with is 248.625. Comparing that to what I want, 270, I can see that that's too small. So I increase my guess to 6.6. 6.6 gives me 261.096, and comparing that to my 270, again I can see it's too small, so I'm going to try 6.7, and when I put 6.7 into this, I end up with 273.963, which is too big. So now I've got it trapped somewhere between 6.6 and 6.7. That means that anything in between those two numbers is going to round one way or the other. It's going to go to 6.6 or 6.7. So here's where I do my test value, 6.65, and the answer when I do 6.65 is 267.47 and a few decimal places after that. Comparing this to my original, I can see that that is too small. So logically my next guess would have to increase, which means that anything between 6.65 and 6.7 to one decimal place rounds to 6.7, which is my final answer there. Well done if you got those all right. That's a really common exam question, trial and improvement. It's very important you understand it. Thanks for watching.